We're back. Hello, hello, hello. Turn that down a little bit. Go. A little softer. Hello, hello, hello. Hello. Okay. Right. Hey, there we go. Hey. Maid, how are you doing, buddy? How we doing, my friend? Hopefully you're doing okay. Ooh, got a cheeseburger. Nice, dude. Yeah, I'm gonna be hungry probably after I'm done here. So, you know, I'll probably go get some breakfast, get some brunch, something like that. Easy peasy, lemon squeezy. Here we go. All right. Alrighty. Got a couple more minutes here and then we'll get started. Say, let me ask you, Brenton. Brenton, are you there? Sure, we have Lori here. Looks like it's just me. Yeah. I'm just currently waiting. I'm not sure where my students are. I told them I would do a makeup class today, so hopefully they come in for this 10 o'clock class. I hope so, anyway. There we go. Nice. Hey, how we doing, buddy? How we doing today, my friend? Good, good. Homework for some Excel class? Fun? Yeah, yes. Playing with Excel all day. So much fun. That sounds like the place to be, man. All right, you know what? I'm gonna wait 2 more minutes. I'm gonna wait 2 more minutes, and then hopefully something good is gonna happen. So I'll wait 2 more minutes here, and hopefully we'll have maybe a couple more people come in. I don't know though, but still, and we'll get started anyway, regardless. So it doesn't matter. There we go. There's another person. Look at that. As soon as I say that, Dr. Dan comes in and says, "Hello, hello, my friend. How are you today, my friend?" Hope everybody feels good here for a Friday morning. A wonderful Friday morning. We'll get started here in just 1 minute. And anybody else who's going to join us will, I guess, join us once once they're ready. So, yeah, I'm doing very good today. It's been a kind of an up and down kind of morning in terms of getting rest, but overall doing okay. I probably should go out and get some coffee after class, just kind of wake myself up a little bit. But outside of that, it's just been pretty chill. I think the day's been okay. I don't think I can sit here and complain. Been a relatively chill day. So, yeah. All right. Okay. So hopefully they'll have a few more people come in. I'm not sure yet, but well, it is what it is, and we'll just kind of go with whatever. All right. Okay, let's get started today. Welcome back to Friday. All right. Today is makeup day for the class that we missed a couple weeks back. Um, so today we're going to be covering chapter 6 here from the textbook. We finished up to chapter 5. Again, the test for chapter 5 is posted and up, so you can go ahead and practice with that once you have the time. Today we're just going to go over chapter 6 in its entirety. There's not a whole lot in chapter 6 here, but it does cover some important topics to hopefully give yourself a nice friendly little reminder about some of the things you learned in the past. All right, so let's talk about chapter 6 here, and a majority of this here in chapter 6 is going to be pretty much using the calculator from a practical perspective, all right, as we go ahead and put, the word problems here together. Now, all of chapter 6, well, actually, I should say, I take that back. a majority of chapter 6 here is going to deal with sign numbers, i.e. positive and negative numbers in some variety. Okay, so what we're going to do here is just take a look here at several of these problems. If you've seen, again, adding, like for example here in section 6.1, let's look at that here. Okay, so if we look here at section 6.1, we'll be adding sign numbers. All right, so adding sign numbers here isn't too tough. Okay, all you have to do is, of course, if you add two positive numbers together, so let's say you have a positive number, plus another positive number, for example here, then of course, like 3 plus 2 is 5, that result's going to be positive. If you have a negative number, take a negative number. Now, if we're adding two negative numbers, that's a little bit different, okay? So let's say we're adding two negative numbers. Now, if you're to do some mental math with this, adding two negative numbers isn't too hard. Again, let's say we have negative 2 plus negative 6. All you have to remember is, in one very important note, is that the answer is negative. Okay, that's really the big key here, is that the answer is negative. Just add the numbers together and tack on a negative, since you know that the answer is negative. So that's why negative 2 plus negative 6 is just negative 8. You just do 2 plus 6, which is 8, tack on a negative since you know they're both negative. Winner, winner, chicken dinner. You got it. Finally, the other one here, which is adding a positive and a negative number. Basically, all we're going to do here is you need to look. Let's talk about the key here. The key here is to look at which number is bigger, the positive number or the negative number. The sign of that number will be in the answer. So if the bigger number is negative, then your answer is going to be negative. The bigger number is positive, then your answer is going to be positive. And all you have to do is just subtract the two numbers from each other. Again, this being bigger minus smaller. Okay, that's pretty much it. So all we have to do here is, let's say we have negative 10 plus 3. So let's say we have negative 10 plus 3. Okay, so really quick here, which one of these, let's take a look here. Is this answer here going to be positive or negative? Is this answer here going to be positive or negative when we add these together? You guys think? Yeah, it's going to be negative, right? Because 10 is the bigger number than 3. So we compare 10 and 3, and 10 is the bigger number here, and that happens to be negative. So what we do know we could take to the bank here is just tack on a negative here to start with. Then you'll have to do is do the simple part here of doing 10 minus 3. Take the bigger number minus the smaller number, and that's 7. So without having to do much guessing, get minus 7. And yeah, that's it for that. Okay, any questions about that so far? Hopefully that ain't too bad. Pretty straightforward. All right. Now that you have a pretty good idea about how to do that kind of in your head, if you want to give that a try, let's look at some problems here. look at some practical problems, and let's see how we can work with those. By the way, good morning, Jasmine. Hopefully you're doing good. Um, okay. Let's look at some life skills problems. All right. Let's give that a go. Okay. Good. Um, okay. So let's look at number 4. Pedro's checking account contained $489 on June 1st. He then made the following transactions: deposited $150, withdrew $225, withdrew $34, deposited $119, withdrew $365, and deposited $750. What was his new balance after these transactions? Okay, so remember that if you deposit, that's adding money into your account, and if you withdraw, that's taking money away from your account. All right, so let's all right, so let's just take a look here at this particular problem. So what we're going to do here, simply put, is we're just going to go ahead and put in the, let's do that. Okay, so he starts off here in his account with 489. All right. Now you can do this on your calculator here. It's really not too hard. If we deposit, we're going to add 150. We withdrew another 225, so we'll subtract by 225. And you could do this all in a row. He withdrew 34 bucks, deposited 119, withdrew 365, and then added 750. Now again, I don't expect you to do this by hand. I'm just showing the setup for the problem here. So again, using your calculator here, can anybody tell me what they got as their final answer here? $884. Okay, good. That's correct. All right, good stuff. Okay. Oh, okay. That's kind of okay, I guess. Let me check that here. Okay, that's fine. All right. All right, good. Any questions about that? That shouldn't be too hard. Okay. Let's try one more here from this section. Okay. There's not a whole lot in this section, guys. I'll be honest with you. All right. So I'll have you guys answer this one here, and I'll set it up for you. So it'll be number what do I want to do here? Yeah, let's give number 8 a try. So excess energy generated by solar panels can often be sold back to the power company. Over a 6-month period, a household consumed 212, 150, minus 160, minus 178, minus 148, and 135 kilowatt hours of electricity from the power company. What is the net amount of electricity consumed by the household? Okay. So can anybody give me an answer for this problem? Minus 124. All right. So let's go ahead and take a look at the setup here. See if that indeed is the case. All right, so the setup here isn't too hard. We'll take 212 plus 150. We're going to add here by minus 160. We'll add here by again and minus 178. Add here by another minus 148. And then add once again here by 135. So again, I just fully expect you to use the calculator for that part there without too much trouble. Get 212 plus 150 plus negative 160 plus negative 178 plus negative 148 plus 135. Okay. So I got a slightly different answer. Yeah, Jasmine got a slightly different answer there. Minus 124, not quite. What do we get here if we add up those numbers together? Got an error on your calculator. Again, probably because you use the minus sign key as the negative key. Remember that the negative key is different than the minus sign key. Anybody else get the answer there? Dr. Dan or Brenton? Either one? Okay. Got 11 there. Hopefully you guys got 11 as well. All right, so 11 is indeed the correct answer for this problem. Good. So just be careful putting in those numbers in the calculator there. When you put in some sign numbers there, the negative key usually is a different key than that of the minus key. So they usually are two different things, especially on a graphing calculator. They are two different things. Okay, 11. Good. 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 Brenton, you good? Okay, cool. All right, excellent. Okay, let's go ahead and move on to the next section here. You can see that there's not a whole lot of stuff here. So we're just going to basically kind of plot along here through these 4 sections in chapter 6. Okay, next is about subtraction of sign numbers. Okay, and I'm going to get to the thing here. Okay, so one of the things when it comes to subtraction of sign numbers here, at the very least, and let's go back to our little document here. So subtraction of sign numbers, the one thing that we have to be aware of here at the very least is that if we take, like, for example here, 5 minus negative 3, in a sense, then we can rewrite this as 5 plus 3. As you may have known here for sign numbers, again, a negative of a, let's try this here. A negative of a negative number is equal to the positive of that number. Okay, so remember, a negative of a negative is a positive. Okay, so let's go ahead and take a look here at some word problems, and we'll see how it works. Really shouldn't be too hard. Again, we will rely again on the calculator there, so that should be fine. All right, let's look at the. Let's go ahead and take a look here at number 2. Okay, the highest temperature ever recorded on Earth was 136 degrees Fahrenheit at Libya, North Africa. The coldest was minus 127 degrees Fahrenheit at Vostok in Antarctica. What is the difference in temperature between these two extremes? Okay, so very extreme temperatures here that we see here in this particular example. Of course, our goal is to go ahead and see what the difference is going to be. So all we want to do here specifically, at least let's show off this problem here, is we want to take 136 and we're going to subtract that from the value of minus 127 to see what the difference is between both of these extreme temperatures. And does anybody have an answer for me here? What's the difference of temperatures here? $263. Good. Because again, this would be 136 plus 127. Again, a negative of a negative makes a positive. So that's where we get the 263 from in this particular instance. All right, so that isn't too bad. Let's look at another problem though. Let's see if you guys can get this. Okay, so let's look at number 9 here, which is at the bottom of this page. Trades management. Pacific Roofing was $3,765 in the red at the end of June. At the end of September, they were $8,976 in the red. Did they make or lose money between June and September? So anytime a company is in the red, then basically that they're running a debt, okay, and they're losing money. They're currently in the process of losing money. If you're in the black, that means you're making a profit. Okay, so in the red, in the black. Hence why we have the name Black Friday, because that's when most retail companies start getting profits from Christmas shopping and whatnot. Okay, in this case though, we want to take what do we want to do here? How do we set up this problem? How are we going to find out if they made money or lost money between June and September? How should we set up this problem here? Okay, that's pretty close. Again, they're both in the red here. So they started at 37.65 and then they ended off in the red even further at 89.76. So we could just take it straight up here. In this case, we can take it straight up. So for example here, we could do, you're pretty close there, Jasmine. You could at the 37.65 here minus 89.76. That's pretty close there, pretty close. All right, does anybody have an answer for me here? Minus 52.11, okay, good. So this would be minus 52.11 here. Or again, another way to look at it is this is basically a loss of 52.11. So this company here lost $5,211 between the months of June and September. So didn't have a very good quarter. Okay, so not crazy, not crazy hard. Just like okay, there you go. Yeah. All right. Any questions about that? All right. Well, that in a nutshell is section 6.2. As you can tell, not a whole lot in that section there. It's just kind of there for the most part. Okay. Again, because we're looking at the practical side here, that's why we're kind of skipping a lot here in terms of like doing the actual doing side. We're just like, hey, let's just use it in applications right away, since we're looking at, hey, where can we apply this stuff right away? Okay. The next part here. Okay, next here is going to be section 6.3, which is going to talk about multiplication and division of signed numbers. Now, what we want to look at here is to remember the rules here for multiplication and division. So let's take a look at both columns here. Okay, so for multiplication, remember if we take a positive number and we multiply that by a positive number, well then our answer here is also going to be positive as a result. If we take a positive number, multiply it by a negative number, well, positive times a negative will be a negative result. If we flip it around, nothing changes. We'll have still a negative times a positive result is still a negative result. And then finally, something that we learned from the last section is if we have two negatives, or again, two wrongs, make a right. So negative times a negative is equal to a positive. Okay, as for division, we have a positive divided by a positive number is equal to a positive. Okay, it's going to pretty much follow the same rules we had for multiplication, but still worth writing down nonetheless. So we have a positive divided by a negative, and that's going to equal a negative. A negative divided by a positive equals a negative. And then finally, a negative divided by a negative will be equal to a positive number. Okay, so these are the generic rules here for multiplication division, regardless of whatever the numbers look like. There you go. You got it. It is what it is. Okay. All right. So again, I'm not stressing this too hard here because again, we're looking at the more of the practical side. We're just, that's essentially what we're looking at here. So it's not intended to be super hard. It's like, okay, these are the generic rules. This is how we use it. Fair enough. All right, let's take a look here at one problem from this section, because there's only really, honestly speaking, there's only like one problem that's really worthwhile. Most of the rest of it is just like, okay, it's kind of there. Okay. All right, so let's go ahead and do number 3 here. Okay, so number 3, as you can see here on the screen, maybe without my face there. All right, move that over a bit. All right, there we go. A lot better. All right, so due to the relative sizes of two connected pulleys, A and B, pulley A turns 1.5 times more than pulley B, and in the opposite direction. If positive numbers are used to indicate counterclockwise revolutions and the negative numbers are used for clockwise revolutions, expressed as a signed number, the result for, and so let's read this carefully here. Pulley A, when pulley B turns 80 revolutions counterclockwise. So what's the sign number for pulley A when pulley B turns 80 revolutions counterclockwise? So let's read this a little bit more carefully. So pulley A and pulley B basically basically turn in opposite directions. So in this case here, pulley B turns counterclockwise, as it says here. So that means that pulley A has to go clockwise, since that is the opposite of counterclockwise. Clockwise revolutions, according to our problem here, will be listed at negative numbers. And we have one more thing to consider. Pulley A turns 1.5 times more than pulley B. Okay. We have all that stuff there just kind of thrown in, but all very important. So we're going to get a negative result here. The thing that we need to figure out is what's 1.5 times more than 80 revolutions. So let's take a good look at that. 80 times 1.5, or 1.5. Can anybody tell me here, what's 80 times 1.5? What's that going to be? 120. That's right. And since we know this has to go clockwise, all right, this is clockwise, then that means that we're going to have minus 120 as our final answer. So this is the type of problem here that you kind of have to kind of read the details. The devil's in the details in this type of problem here. All right, so it seems like there's a lot, but once you pick apart the pieces, it's not as bad as it may seem. Okay, let's take a good look here at, not that. Let's take a good look here at the second part, and let's see if you guys can figure this out. So here we want to find pulley B when pulley A turns 60 revolutions clockwise. So what would be the numerical equivalent there? What would be the numerical equivalent here? Pulley B when pulley A turns 60 revolutions clockwise. What would that be? That be there. What do you guys think? 90. Now you got to be a little careful about that one. 90 would be the answer here, but pulley A turns 60 revolutions clockwise. Pulley A turns 1.5 times more than pulley B. We actually did it the opposite way. We're actually not going to multiply by 1.5. Want to actually do the opposite for that one. Want to divide by 1.5. Pulley A will always turn more than pulley B. Hey, Jake Ruby, how you doing, buddy? Bernie, thanks for the follow, buddy. Came here from Lee. Hey, man, thanks for the follow, buddy. Appreciate you. All right, so we get 40. And so 40 here is going to go counterclockwise because it has to be opposite. So this will be positive 40 here as a result, according to the context of the problem. It is 40, it is 40, Brenton. Nice. That is correct, sir. You got it spot on, my dude. All right. Sure. That's not a problem. If you'd like to listen just a little bit, that is not a problem, my friend. Yeah, good job, Brenton, man. Nice. All right. So there's not much in this particular section here. Again, most of the applications here are pretty relatively straightforward. They don't require too much effort. But again, we can see here that, of course, just like in any word problem, the devil's always in the details. We just got to be a bit careful about that. But once we get that down, we should be good to go. All right. Any questions about that section there? Hopefully for sign numbers there, that's not too hard. Positive, negative stuff. Probably stuff you've seen before. But still. Nope. Okay. All right. Let's take a good look here at this last section here in Chapter 6. So Section 6.4 will be talked about here in a little bit more detail. It talks about exponents and square roots. Okay. Let's go over the basics here about how exponents and square roots work. Exponents can be written in the form of, let's go ahead and put that as an equation. Like equation. Very good. So of course, things can be easily written here as, say, x to the some power here. Let's call it x to the third power, for just a quick example. Now, if you write anything to, say, the third power, the fourth power, whatever, it doesn't really matter. Again, that's just an example for an exponent here. Here we have two parts. So let's talk about each part here, because if you understand exponents, it's really kind of one of those things that is rather important because you do use it quite often. So x here is what we call the base. So this is what we call the base. And let's say the 3 here, or whatever you want to call it here, the 3 or the 4 or whatever. This is the exponent itself. Okay. Now how we figure this out here is fairly simple. For example, x to the third here, as just by itself, would equal something that wouldn't look so tiny on the screen. But more importantly here, it would equal x times x times x. Okay, so just 3 x's, whatever those numbers are, you're going to multiply them by each other. Now, let's talk about one of the most important things in regards to exponents, though, is that, yes, okay. Let's make a very important note here. Parentheses matter. Parentheses matter a lot in exponents, okay? Let me go ahead and demonstrate it like this, Okay, so if you have a calculator or not, it doesn't matter. Let's take a look at both of these cases. So let's take a look at let's look at minus 3 squared and minus 3 squared. Okay. Now, if you look at minus 3 squared here, this first case that you see up there, what's that going to equal to? What's that going to equal to? You got minus 3 squared there. What do you guys think? Minus 3 squared without the parentheses. You can enter that in straight up in your calculator. Just straight up. Minus 9. All right? Fair enough. So we have minus 9. Nice. Now let's do it with parentheses. Negative 3 quantity squared. So let's do it with parentheses. What do we get here in this instance? Nine. That's correct. So there's the key difference here. Without parentheses, it's minus 9. With parentheses, it's positive 9. You cannot make the assumption that it's going to be the same answer every time because parentheses matter. Remember, with negative 3 quantity squared with the parentheses, that in effect is negative 3 times negative 3. And as we just talked about here, a negative times a negative is a positive. Remember that the calculator by itself is not a very smart thing. In fact, as my old professor said, the calculator is very, very dumb. All right, the calculator will do exactly what you tell it to do, and that's the problem. Since you tell it exactly what you want it to do, it may not do exactly what you intended it for to do. So, majority of the time, why the calculator spits out wrong answers really comes down to human error. So you just got to be a little bit careful about that, so you're not like caught in, caught getting bad answers there. So again, if you have the graphing calculator there, put parentheses around those numbers there. That'll be very important if it requires to do so. Okay, so I never take it for granted. I take a look at what I got, and then I just work with it from there. Okay, I did want to point that out there as well. All right, let's also talk about one other thing here. Remember that in this case here, so just as a nice little note here, do not forget the order of operations. So don't forget order of operations here. So remember we had our order of operations was PEMDAS, or please excuse my dear Aunt Sally, or whatever you want to call it. Doesn't really matter. P was for parentheses. E was for exponents, so this is where we go ahead and do that. M and D here were for multiply, divide. Remember that multiply, divide here is the same rank. And then of course we have add, subtract. Okay, so order of operations still hold, just as they normally do. Now that we have, we're using exponents here, perfectly fine, no problem. Okay, I need to talk about, so I need to talk about here. Maybe do a problem here with that in just a second. Okay, all right. So I do want to point out at least a couple things here in regards to exponents here. So why don't you guys tell me here, what is 3 to the 0 power? What is 3 to the 0 power? So let's say I had a power of 0. What is 3 to the 0 power? Can anybody tell me there? 1. That is correct. So one of the rules that you can take to the bank here is if you have a to the 0 power, doesn't matter what number it is. It could be a billion. It could be 7. It could be minus 11. I don't really care what number it is. But anything to the 0 power is automatically 1. So the answer is actually not 0. The actual answer is actually 1. One of those little subtle things that you may run across in some of the homework problems. I just want to be sure that that part is taken care of. Okay, let's do a very quick problem here with exponents and all that jazz. So let's do this one here. Very quick problem here. So, all right, so we have 28 divided by 7 squared minus 14. Again, we want to follow the order of operations here. So again, you want to do parentheses first. Okay. So essentially, Jasmine, that is a rule of exponents. Okay, anything to the 0 power is automatically 1. It is a very set rule of exponents. So yeah, you could also take a look at a graph there, but yeah, we use that as kind of a placeholder. So 0 is always like, okay, you just start at the beginning at 1. So it just is. Yeah, you could kind of call it that, yeah. Or again, what would be another way to kind of put it? Oh, you're not multiplying by 0. That's why it doesn't work that way. Because if you were multiplying by 0, then in effect, I'll put it this way here. I'll do it this way. There's one way I can actually show this out. So if I had 3 squared here, for example, I have 3 times 3. But another way to, that was, because I got 2 3's I need to multiply by, and then of course I get 9, okay? So that wouldn't be a problem. But there is one more way to actually write 3 times 3 or 3 squared. Another way to write that is going to be 1 times 3 squared. I can write that because 1 times anything is always that same number here nonetheless. Now what would happen here if I had 1 times 3 to the 0? Well, in effect, I don't have any 3's of which I have to write down. So the only thing I'm actually left with is 1. That's it. So you can kind of reason it out that way as well. So if you want to know how that kind of works, at least from a logical perspective, that's how we can actually look at it from that way. I hope that answers that question a bit. Okay, cool. So just some simple manipulation, but it's not so obvious because it just seems so so stupid to kind of just say 1 times 3 to times it to the 0. But when you think about it logically, like, oh, okay, yeah, that's kind of a thing. So all right, that's fair. All right, let's go ahead and do this sample problem we have here. So here we have 4 to the 2nd power. We'd always do the parentheses first, minus 14. And so we do 4 squared, which is 16, minus 14, and we get a grand total here of 2. All right, not terrible. It's a thing. There it is. Congratulations. Pat, pat, pat. Great job. Yes, yes, yes. Of course. All right. Any questions about that? I don't find that to be like super duper hard, but I just want to be sure that you guys knew where that was coming from. So, no, you're like, oh my god. Ah. Okay. All right. Now, let's look at the next part here, which is talking about square roots. Okay. Let's at least break down what square roots are. Sorry. Okay. Now, square roots are a little bit of a different deal. All right. Square roots basically are going to apply and say, all right, I basically when I learned square roots when I was doing this stuff here, and I wanted to learn square roots, the easiest way is I would ask myself the same question over and over again. And so I would say, okay, well, um, if I took the square root of a number a, it could be a could be any number that you want. Okay, it doesn't really matter to me. Okay, this basically to me translates into one very important question. This says, what number squared is equal to a? So whatever I'm taking the square root of, there's some number squared that I have to take, and that equals a at the end of the day. Okay? So this is basically the key here for what I want to reflect here for everything revolving around square roots. So our goal here, specifically after this, our goal here is to find out the question mark here. Okay. Now, it's not going to be necessarily so easy to figure that out. Okay. Sometimes you could be dealing with different numbers altogether. Now, there is a chart here in the book in regards to the first, I believe they went up to 20. Yeah, they went up to 20. So I'm going to go to that page right now so you guys can see. Go here. So this is going to be on page 406. Okay, so there's going to be a chart there on page 406, and this is the perfect squares chart here. Okay, so this is the perfect squares chart here on page 406. So okay, so if you're good with the perfect squares chart, then this isn't going to be too tough. But if you're not very good with the perfect squares chart, at least you have something handy that you can look at. So again, 1 squared is 1, 2 squared is 4, 3 squared is 9, okay, 4 squared is 16, 5 squared 25, 6 squared 36, 7 squared 49, and so on and so forth. You get 64, 81, 100, 121, 144, 169, 196. Let's see, that's 29 off. So 225. Let's see this 31. So 256. 256, 33, 289. 289, 35 is going to be 324. Yeah. All right. And I think you get the general gist. All right. All right. Anyway, there's an actual pattern here, by the way, to the perfect squares chart. So if you don't see it right away, that's okay. But here's a good way that you can memorize it. Well, 1 squared is 1, that's fine. And 2 squared is 4, pretty simple. The difference between 1 and 4 is 3. Add 2 to that, which is 5. So if you add 5 to 4, you get 9. Add 2, which is 7. Add 7 to 9, you get 16. Add 9, 25. Add 11, that's 36. Add 13, that's 49. Add 15, that's 64. Add 17, that's 81. Add 19, that's 100. You can get the general idea about the difference here does actually form a pattern here of distinctly adding 2 each time to the difference between the previous one. So yeah, there is an actual pattern to the squares that you can actually get. All right. In any case, we certainly have that here. So let's take a good look at some problems here. Let's see what we'll get. Yes. Let's do it. Okay, so let's look at the square root of 81. Again, we're going to look at the idea here of, let's ask the question here, what squared is equal to 81? So that's the question that I always ask myself. What squared is equal to 81? And again, it's not like super hard here, but again, that's correct. Very good, Jasmine. So we have 9 squared is equal to 81. So 9 times 9 here is equal to 81. So that would be our answer for that problem. Okay. Let's look at another one here. Sure. How about the square root of 196? So what number squared equals 196? 14, that's correct. So again, we can take a look back at our chart here. And we can see here, look, as you can see here, we have 196 over here. And we see that 14 squared is equal to 196. So there's a way we can physically use the chart here in order to help ourselves out. Let's go ahead and do one more here. Okay, what's the square root of 289? The square root of 289. 17. Nice. Good. Easy peasy lemon squeezy. All right. Questions so far about that? Yeah, nice. Okay. Now, the next part I want to kind of focus on here, really quick, of course, for the word problems especially, is going to come down to one very important thing. So let's talk about that right now. That important thing is, of course, entering in what we need to have here in the calculator. So once again here, the calculator is going to be our best friend here for some of our word problems, as they, in this particular section, they already set up the problems for you. It's just a matter of practice and getting the correct answer there on the calculator appropriately. So let's take a good look at a couple of those problems, I should say, and we'll see how it works. Okay. All right. Let's take a good look here at number, yeah, let's do that one. Let's look at number 6. Or actually, no, number 4, actually. Look at number 4. The resistance in ohms of a certain silicon diode is found using the expression the square root of 15 times 10 to the 6th times 24. Calculate this resistance to the nearest 1,000 ohms. All right. So this is basically a straight up calculator type problem here. And I want to be sure that you guys are using this appropriately here. So if you have the graphing calculator there, that's going to be super helpful. If you don't have a graphing calculator there, that's okay. First thing that you want to do is figure out what 15 times 10 to the 6th times 24 is going to be. And it's going to be a pretty ridiculously large number. But if once you get that number there, take the square root of that number using your function on the calculator for square root, then you should get an answer here in this case. So trying that out, what did you guys get for your answer in this instance? Anybody have an answer for me here? Okay, very good. That is correct. 18,973.6 repeating here. All right. 6 actually 6 7. I'll put 6 7 actually. That's not really correct. I'll put 6 7. There we go. Fine. Same thing here, but that's fine. Okay. Nice, 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 nice. Any questions about that? We'll see. Yeah. Ah, no. Did you guys get that? Brenton, you get that? Dr. Dan, you get that? Just want to be sure you guys got that correct on the calculadora. Yes, perfect. Okay. Okay. Not sure if Dr. Dan's online, but if he is, then hopefully. Yes, okay, perfect. Nice. Okay, very good. All right. Now let's take a look at this final problem here. And this will be a good problem here for what we're going to be doing here for next time, which is talking all about algebra. But this is a very good problem here because, again, this is going to be the types of problems that we're going to be seeing in the next chapter anyway. So a nice little preview here that I do want to do nonetheless here. Let's take a good look here at number 8. Number 8 says the length L of a rafter on a shed roof is calculated using the formula. And here they give us the formula. L is equal to the square root of h2 minus h1 squared plus w squared. Suppose that h2, the maximum roof height, is 13 feet. h1, the minimum wall height, is 7.5 feet. And w, the width of the shed, is 12 feet. Calculate the rafter length, not including allowance for the overhang. All right, around the nearest tenth. All right. So essentially what we want to do here is, and kind of what I want to demonstrate, at least in this particular problem, is you just need to be, just know what each of these variables mean. So again, if they told you h2 minus h1, you're going to need to know what the context of the variables are going to mean. So for example, h2 here is the maximum roof height, okay? h1 here is the minimum wall height, right? In certain formulas here, especially when you're doing math, of course, knowing the context of each letter will be fairly important. That way you know where to plug stuff in once you're given the information, or at least find the information during the process. Just don't forget what gets substituted and what doesn't get substituted. Pretty important. All right. So let's set up this problem here, and we'll talk about one more thing here. Hard for this problem. Okay, so I'm going to go ahead and put this in. Okay, now let's go ahead and put in our numbers here. So this is going to be something that is going to be very, very important here as what I'm going to put in next. Okay, H2 here is going to be 13 feet. So 13 is going to go right there. Minus H1, which is 7.5 feet. We'll put 7.5 here. And then this quantity will be squared. We'll add that to the width squared here, which is 12. I want you to take a look at what I did here in this part. Okay? I want to show this off here because if there's one thing about mathematics that can get fairly confusing, whether you're doing something by hand or not, and we've already alluded to it today, but I want to reiterate this here. You see that I intentionally put these numbers that we were given here in parentheses. I do that on purpose, okay? One of the things that's important here, so important, always put parentheses around stuff you substitute. If there's one thing in math that'll be very helpful, it's pretty much that this is one of those things, besides of course balance and things like that, that is extremely helpful here into making a whole lot more sense when using formulas. Now, the reason why I use parentheses here is because a lot of processes involve changing sign numbers. Okay, so signs can easily change. So because signs can easily change, and we're going to look at some examples in the next chapter where that's definitely the case, because signs can easily change, we have to be aware about what happens in that case. Because if this was, say, minus 7.5, well, then this becomes minus 7.5, and then that becomes a plus instead. Okay, obviously in this context it makes no sense, but what I am saying is that you still have to be aware about what if you're plugging stuff into a formula, you just need to know if sign changes or not. And it's easier if you can physically see that when you put parentheses around it. Again, we don't take parentheses for granted. If you have the parentheses there, you'll be much more consistent in doing the process out. So that's one thing that I do want to actually stress here very greatly. Definitely very important. So here we have 13 minus 7.5. So if we do that out, we're going to get 5.5 squared plus 12 squared. Okay. So I'm just going to do this in steps here. So here we get 30.25 plus 144. So here we get 174.25. All right, does anybody have an answer for me here? What is the square root of 174.25? We'll go to a couple decimal places, so 13.2, all right. That was on the money there. All right. Good stuff. Okay, there any questions about exponents and square roots? So you guys got that down? You notice you could break it down, or again, try entering in a bunch of numbers at once in a calculator is pretty time consuming and usually will end up to be not in the greatest of shapes. So want to go ahead and just take it as easy as possible. Any questions, anybody, about any of the material here for chapter 6? As you can tell, the material here for chapter 6 is pretty light. But again, it does help set us up for chapter 7 here, at least kind of the beginning throes of understanding algebra. So that's essentially what we're going to be doing here starting next week is doing the algebra chapter. We'll be skimming some parts of chapter 7, so we're not going to be doing every section of chapter 7, but we'll be skimming a few parts there as well. So we'll just need to be a little bit careful about what we're going to cover, because some of the parts there is just kind of like, okay, they're there, but they don't add a bunch of substance. So we want to look at the more of the algebra break portions that add a lot of substance for what we're going to be doing. So any questions at all from anyone? Uh, off again. Okay, so that will take care of our special makeup session here for today. Um, Guys, I want to thank you all for coming out here to my stream once again. Thank you for coming out to this makeup stream. Again, I really apologize about last week, but I hope I've made it up to you today for the for making up for the material there. So I wanna thank you for coming out on a Friday. Yeah, I'm sorry about what happened previously, but I hope I've made it up to you with this class here today. Um, like I said, I don't like missing class, especially for reasons, even if that reason was kind of out of my control with the internet going down. Yeah, I'm not going to deprive you of time that not only we should have had, but time that I felt was very important as well. So can I email the notes? Absolutely, my dude. I can definitely do that. Let me save that right now so you can see that I'm doing what I'm supposed to be doing. I'm supposed to be doing things. There you go. You mean you have responsibilities? Oh my god! I don't believe it. How could you? All right. All right. Thank you again, everybody, for coming out to my very quaint stream. I really appreciate the time, the energy, the effort. All right. I love you guys. You guys are great. You guys make this worthwhile even on a Friday. I still love doing what I do only because you guys also make that effort as well. So I really appreciate that very, very much. All right, you guys. I'm going to see you on Monday, same time, same place. Okay? Everyone, please enjoy your weekend. Stay safe, stay happy, and stay healthy. All right? All right. Take care, everybody. And we will see you after this weekend. Okay? Have a great one, and we'll see you. All right. Take care, everybody. Okay.